Okay, good morning, everyone. The way we always start basically every class is by me asking you, how did the homework go? Okay, how did the homework go and which questions you had struggled with? And we go over every problem you had any difficulties with. So I usually like you to ask me questions. Okay, I struggled with this problem, or I struggled with this problem, and you go over them. All right, so that's really how the course will work. So on chat, I would like you to tell me which problem you had difficulties with from the homework, and you go through them. Okay, I like that. So I have number 15. And anybody else has difficulties with any other problem, please put them on the chat. That's how you're going to learn, by working out problem together. All right, so while you guys put your problems, as an opening for all of us, this is a graph I have in front of you, and very simple, just as make sure that you got the idea. And I want every one of you to look at the graph. I want you to find the period. So I'll give you 2 minutes for that, the amplitude, and the midline. Okay, so you have 2 minutes. Okay, to do that, and then I go back and I start looking at your homework. Okay, so 2 minutes to do that. Then I'm gonna pick one of you to give me the answer they found. Please keep your camera on for those who don't have it, because it's very helpful for me to see your faces, as I said last time. Okay. Are we ready? Who would like to volunteer instead of me choosing? If nobody volunteer, I will pick. Anybody like to volunteer? Okay, somebody did. So the answers they are giving me, the period is 10. And the amplitude, they are giving me 4. The midline, remember, the midline is a line. So I will not accept midline equal to 3. You have to give me an equation. Y equal to 3. Are they correct? Let's check them out. Let us check out the period. First, what's the period? We start, you can start anywhere and go through the graph and start asking yourself, when does the graph start repeating itself? So I'm moving along the graph, I'm moving along the graph, I'm moving along the graph. And then after that, I see that the graph kept repeating. So that's a cycle. That's one cycle. So how long it took for it to start repeating? It took 10 units. So this is my period, 0 to 10. Okay, so you just follow the graph, verbatim. So period correct is equal to 10. Now, part 2 is the amplitude and the midline. All right, let's see if they are correct. Before finding the amplitude and the midline, we need to find the maximum value of the function. So let's see what's the max. the highest value obtained by the function, and what's the minimum value obtained by the function. All right, let's see here. If this is 6 and this is 8, so the maximum is obviously 7. That's the highest value that the function reaches. The minimum value is somewhere in between, right there. So the minimum value is a -1. Okay, they are crucial to find the amplitude. Very good. Now, I want the amplitude. And like last time, I want to do it basically by eyeballing it very carefully. Second, I will use the formula because I insist that you can do it both ways. So the midline is halfway between 7 and -1, exactly halfway. So between 7 and -1, how many units we have? 1 unit and 7. So here we have 8 units, basically. So half of them is 4. So the midline should be, I can either count 4 from the top or 4 from the bottom. So I need 4 units. So this is 1, 2, 3, 4 units. I'm right here. So that's the midline. Means that from here to here, I have 4. That's halfway through. That's 4. And from here to here, I have 4. So that's, and this should be a 3. So 8 units, half of them is 4. You can either count 4 from the top or you can count them from the bottom. You need 4 units. So if I count them from the top, I have 7, 6, 5, 4, 3. 1, 2, 3, 4 units, or 1, 2, 3, 4 units. Regardless how you go, that's halfway in between. So this is my midline. So this is y equal to 3. So they are correct. And the amplitude is the distance between the midline and the highest point. So that's my amplitude, which is equal absolutely to 4. So their answer is correct, right? So this is by really understanding the meaning. Now, if I want to use the formulas, which would give me that. So now let us use the formula just to double check. Okay, let me remind you how the formula works. The amplitude is the maximum value that the function gets minus the minimum value the function gets divided by 2. That's the formula for the amplitude. Now let us see if it's checked up with us. The maximum value is a 7 minus the minimum value is a -1 divided by 2. So this will give me 8 divided by 2. 8 is actually the distance from here to here. That's really what the 8 represents. Divided by 2, that's giving me the amplitude, is equal to 4, which is correct. The midline. There are several formulas for the midline. One formula is, basically, the midline is from here to here. So the midline is, one formula for it is, you take the minimum value, you add to it the amplitude. The minimum value is -1. The amplitude is 4. This is equal to 3. Okay, that's how we find the midline. There is actually another formula because some of you will be, of course, you're engineering. Another formula for the midline, another one that I want you really to be aware of it. Another formula is you take the minimum, you add the maximum to it, and you divide by 2. So there are several ways of computing the midline. I mean, you can spot it as we're doing it, or you can use this. So let me apply this. So that's an or. It means you can use either one. So the minimum is -1. The maximum is 7 divided by 2. 6 over 2 is, of course, equal to 3. Okay, so to find the midline, you can either eyeball it the way we've done it, or you can use those formulas if you like. That's really it's up to you if you want to use those formulas. It's nice to use to check that what we did is absolutely correct. Right. Questions before we proceed? Questions, please? All right. So this is basically a review. Now I'm going to go to your problem, and you're asking me about number 15 in the book. So let's see what the number 15 is. Right. So what's number 15 about? Do you guys have the book? Do you guys have the book? Because I had a lot of emails, students having difficulty with the book. So please make sure you have the book, because I will always assign problems from the book itself. I'm sorry the book is expensive, but that was not really my choice. So in the following problem, let me read it. I hope you guys have read it. So if you don't have the book, you need it. No question asked. Please get the book. You board the London Ferris wheel, described in this section. So basically, it's just a Ferris wheel I did last time, but the London Ferris wheel is 200 feet in radius. That's really what it is, just by looking up at the book. And graph h equal f of t, your height in feet above the platform 10 minutes after the wheel begins to turn. Label the period, the amplitude, the midline, as well as both axes, and each case determine an appropriate interval for t. So number 15 is the London Ferris wheel has increased its rotation speed. We don't need that. The wheel completes one full revolution every 10 minutes. You get off when you reach the platform after having made 2 complete revolutions. So it's basically like the problem with it as an opening last time. So let us do that. So here the radius is 200 feet. So let's see the picture. So I'm done with the book for that. So now again, we have this Ferris wheel. This is my Ferris wheel. Okay. And this is the platform. The platform is at ground level here. And this Ferris wheel is 200 feet in radius. So it means from here to here, we have 200 feet. From here to here, 200, 200, and so on and so forth. Okay. At t equal to 0, you are going to board it from the platform. So at t equal to 0, you write here. And it takes 10 minutes for one revolution. So 10 minutes for one revolution. Okay. So what does it mean? At t equal to 0, you are right here. That's where you start. And 10 minutes, it means you go around, 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 around. After 10 minutes, you're back. That's really what it means. 2 revolutions, it means you go around another time. After 20, you're back here. Okay, that's really the picture. Now let us keep analyzing. If at t equal to 0, you're here. And you start moving. So we are at t equal to 0. At what time you will be here? Let's see. Jacob, at what time? Jacob, I'll be calling you also. I want you to stay with me. At what time you're going to be here? 10 minutes for a revolution?
You're going to be there at 2.5 minutes.
2.5 minutes. Absolutely.
I think the confusion is what everybody is wondering is where you're getting the height from, because in the problem, it doesn't give you the height.
Because you're right, because they tell you, you board the London Ferris wheel described in this section. So basically you have to go back to the book and see what's the London Ferris wheel's radius. Are you with me?
I am. I just, I was looking for that Ferris wheel and I actually couldn't find it either. I see the one for Vegas, Singapore, and there's another place, but it never gives, I don't find it for the London one. So
it's not there. Honestly, does it matter?
I mean, if you want to solve the problem accurately, I think.
I know, but I mean,
up to you.
Really, yeah. So that's the one in Singapore. It's asking for give no height. Okay. So you're right. So let us take it to be 200. So now here it is. Here it is. Here it is. The London Ferris wheel is 400 feet in diameter. All right. So it's right there. It's right there because I remember looking it up. So it's 400 feet in diameter. It means 200 feet in radius. Okay. So now, so since I'm talking to you, Jacob, complete the picture. What's t equal to? Right there.
It's 5 minutes.
5. And now it's becoming easy. This is
7.5.
7.5. 10. The second revolution.
12.5.
12.5. The second revolution.
15.
15. Second revolution.
17.5.
And then t equal 20. Okay, now the height. I'm going to make a table just so height, it means h of t, that's a function. That's a function. Represent the height after t minutes. Now the good time is definitely 0, 10, and the time in between. So if I'm going to graph anything, that's what I will be interested in. And 7.5. And of course, we're repeating this, totally periodic. 12.5, and it's 15, 17.5, all the way to 20. And once we do that, the graph will be very simple for us. And this is actually like the one I did on the board verbatim. At 0, since we are moving from the platform, the height is 0. At 2.5, since we decided the radius is 200 feet, I am at 200. After 5 minutes, I am at 400. After 7.5, I am back to 200, down to 0. And my values repeat. 200, 400, 200, 0. So finally, the graph. And the graphs are absolutely crucial. So the graph, we have 2 axes. On the horizontal axis is the time in minutes. On the vertical axis, it's the height in feet. So that's what they mean by labeling the axis. Now, what time we're interested in? Since we have 2 revolutions, it means we need to go from 10, 20. Now we know that something interesting happened at 2.5, at 5, at 7.5. I definitely want to mark those now. At 12, and this. So this is going to give me 2.5, and the 5, 7.5, and then we proceed. 12.5, 15, and 17.5. Those are the points that I'm interested in. Now the height is 0, 200, 400. That's my 0. So I'm going to put 200 here, and my 400 right there. And now I just copy. At t equal to 0, I am at 0. At 2.5, I am at 200. At 5, I am here. At 7.5, I am here. At 10, I'm here. And then we connect dots. And then we come back here. Up here, back, and that. So how is my graph going to look like? So my graph's going to look like this. It's going to back up to 12, back down, come back here. That's the heart of it. And then it's actually a shift. Then the values of the height are going to repeat themselves, totally repeat. So if I am very careful, those two should be exactly the same. So probably I won't have them exactly the same because I'm doing it by hand, but I'm trying to have them this end of the picture. Okay. Right. Before I move on, let me ask you a question, which is basically relevant to problem number 23. Did you guys do 23? How about number 23? Let us say, I'm going to ask you the following question and you answer. Let us say that the Ferris wheel, the platform, there is a difference. Okay, so when you board it, you don't board it exactly from ground level. Suppose the ground level is here. That's the ground level. Okay, it's the same picture, but the ground level is here. And the Ferris wheel is a little bit above the ground level. So let us say from here to here, I have 4 feet. So when you board it, you have to take some kind of a stairs in a way, and then jump into the Ferris wheel. How will this affect the picture in this problem? H of t is always the height above ground level, so nothing changes. But the ground level is not right at the Ferris wheel. It's 4 feet below the Ferris wheel. How will this change the problem? It will add 4 to the height across the board. Absolutely correct. So if this is the ground level, how the picture is going to change? So the height here will not be 0 anymore. The height is going to be 4 because we are 4 feet above the ground level. This will not be 200 anymore. Actually, this is going to be 204. This is going to be 404, and so on and so forth. So that's really how this will change. How the graph will be affected. How the graph will be affected. Will we have the same graph or the graph will change? Lucas, what do you think will happen to the graph?
For the graph, you have to start like 4 feet, so it would be +4, and then the heights would be at 204 and 404.
So the graph is basically going to be totally shifted up by 4 units.
Yeah, shift up 4.
Shifted up by 4 units. So this will go here. This one will go here. So that's the graph. The graph is going to all the way be shifted up by 4 units, which makes sense. Shifted up. So that will be my graph, which is so that will be shifted up, shifted up, shifted up, shifted up. So that will be the difference. So we have to make sure that we read the problem very carefully. Where is my platform? So if we don't really move from ground level, we move a little bit up, this will be the graph. Okay, very good. And this will be, I think my memory is like number 23. They shift you up a little bit. Any other question from the homework before we move on? Yeah, it's shifted up. Yes, absolutely. Okay. So today we're going to move on to section 7.2. And you're going to start the introduction to trigonometric functions. So introduction to the sine and cosine. Actually, it's the most crucial idea will be discussed today. So section 7.2, sine and the cosine function. Okay, the sine and the cosine function. The sine and cosine. Function. Okay. Before I start the sine and cosine and talk about it, you don't have to write anything. I just want to remind you something because I know most of you have seen this somewhere. So let us recall what you guys have seen and what we are going to be doing in this course. Let me recall something. If you have a right triangle, and that's crucial, my wording. Right, it means one of the angle here is 90 degrees. Okay. And I take an angle here, any angle. Let me call it theta. So this symbol that we're going to use a lot, theta, an angle. All right. Let me ask you a question. First of all, the angle theta, this one, what's the maximum value it can have? Back to you. What's the maximum value it can have if I am in this right triangle? Anybody? Matthew? What's the maximum value this angle can have? Not 45. Why? No, it cannot be 180. You are in a right triangle. So this angle theta should be always less than 90 degrees. It cannot be even 90. It can't be 90 because you are in a right triangle. So this angle, the maximum it can take is less than 90. It cannot take even 90 because you are in a right triangle. In a right triangle, this angle plus this angle should be at most 90. So it has to be strictly less than 90. It could be 89.9, but it cannot be 90, strictly less than 90. So it's a it's less than 90. Now, if you remember your high school, wherever, what was your definition of this, at least the sine? I don't care about the cosine. What's the sine? Do anybody remember? I know we're going to review all of it, but I want to bring you back to what you know, what I think you know. The sine is always defined as the opposite side divided by what we call the hypotenuse, which is this side. Anybody remember this definition? Okay, so that's the opposite over the hypotenuse. So that's what you call, you guys will have you seen in high school. And sometimes this is called the right angle definition. Or some people call it the carpenter's definition of sine and cosine. Because carpenters only work with right triangle, right? So this is what you guys know as far as the sine. And the cosine is the adjacent over the hypotenuse, which is, so that's what we know. Okay, so what's the issue now? This makes sense. This definition that you guys know makes sense in a right triangle. It means when the angle is less than 90 degrees. That's really what it makes sense, only that. So according to this definition, if I give you the sine, I told you find the sine of 120 degrees, you look at me, it doesn't really make sense. So what we know is only defined for that. The goal of this course is basically to extend this definition so that we know what do we mean by sine 120. So we're gonna actually give meaning to the sine of any angle, not the angle less than 90 that we can restrict them in a right triangle. Okay, so the goal today is we're gonna give a new, not a new definition, we're actually gonna extend this definition to find the sine and the cosine of any angle. And that's really the goal of the trigonometry. Okay, so the goal is basically to extend. Goal is extend the definition. Extend the definition of sine and cosine and tangent and cotangent, which we'll be talking about them, to any angle, not necessarily angle less than 90 degrees. All right, so that's really what we're gonna start accomplishing today. Now, before we get to that, it's going to be very soon, I'm going to talk a little bit about angles and angle measurement. So before we start the sine, I'm going to talk about angle measurement in a circle. So angle measurement in a circle. Measurement in a circle. Okay. So suppose I have a circle, and I'm going to draw it by hand. Okay, I'm going to draw it down here, a circle. Okay, that's a circle. And let us say I tell you the following. I tell you, mark an angle. Mark an angle of 30 degrees on the circle given. Okay, suppose we have that. What do I mean by mark an angle of 30 degrees? How are we gonna draw the angle? Where do we start from drawing the angle? So if you are on a circle, I tell you mark an angle of 30 degrees, you tell me, okay, where am I supposed to start the angle? You know, I mean, this is an angle of 30, or this is an angle of 30. So what do you mean by mark an angle of 30 on the circle? Okay, so these are the conventions we use. I mean, always use first. All the angle, when I tell you mark them on a circle, all the angle will start from the positive x-axis. So when I'm gonna tell you, draw them on a circle, you have to start counting them from the positive, from the positive x-axis. Crucial. Positive is crucial. Okay, step number one. So I'm gonna tell you, mark an angle of 30. Now you have really to tell me, okay, where to mark them from? We always start from the positive x-axis, and that's how we start measuring the angle. Part two. Counterclockwise, moving counterclockwise on the circle, counterclockwise is defined to be positive angle. Positive angle. And clockwise is defined to be negative angle. So these are the convention we use. Okay, those are the convention we use. So let us say now, mark an angle. So first, angles always on a circle. We start from the positive x-axis. Counterclockwise is defined to be positive angle. Clockwise is defined to be negative angle. So now if I tell you, now my language is becoming much clearer. Mark an angle of 30 degrees on the circle. We always start from the positive x-axis. So I start from here, and then from here, I'm gonna move 30 degrees. So we should have a little bit of an idea about 30 degrees. 30 degrees, it means almost up to here. And this is how I mark my angle on the unit circle. So that's the 30 degrees. So always from the positive x-axis, okay? Counterclockwise, so that's the counter, the clock move. So that's counterclockwise, that's the positive. So mark an angle of 30, that's my angle. And this side here, a lot of time, the book doesn't, I think, use it a lot. This is sometimes called the terminal side of the angle. Because the beginning is always on the positive axis, always. So that's the terminal side of the angle. So now let us say, if I tell you mark an angle of -30. Now my language has an angle of -30 degrees on the circle. I'm going to mark it on the same circle. Now I have no confusion. I start from the positive axis. That's where I start. -30, it means I move clockwise 30 degrees. It means I'm starting from the positive axis and I move clockwise 30 degrees. That's how I move. And this is my terminal side this time. And that's what we mean by -30 degrees. Okay, so the measurements is 30, but we move in the clockwise direction. All right. Now, before we mark more example, let us see a question that I think most of you know the answer to it, but I still have to make sure all of it. How many degrees, if I have a circle from here to here, that's my circle, okay? And this is my circle. How many degrees we have, if we start from the positive x-axis, we keep going around, come back here. How many degrees do we have? Anybody know the answer? I'm sure you do, but I will talk about it. Samantha? We have 360. Now, so from here to here, we have 360 degrees. Now, 360 degrees is a unit of measurement for angle. And this degree is like an inch. So it's a very arbitrary unit of measurement. Okay, the same way inch is arbitrary. Somebody decided is from here to here is an inch. Also, somebody decided that if I take the unit circle and cut it into 360 pieces, physically cutting it, actually the Babylonian long time ago, this 360 piece, every one of them is 1 degree. So a degree is really very tiny. Where is the 360 coming from? Ask the Babylonian. They were the one who decided that's what they want. So it's a very arbitrary unit of measurement, exactly like the inch, which is another arbitrary unit of measurement. So that's the little degree. So around the circle, that's the convention, we have 360 degrees. So with this in mind, I want you to draw the following. We're going to draw it together. So mark the following on the unit circle. So mark the following angles. Just to have a lot of flexibility on the circle. All right. So first I want to mark 180. Then I want to mark 90. So they are so crucial. And then I'm going to mark -90. Okay, so I'm going to mark every one of them. So on the circle, so I'm going to draw a circle. I need a pencil, so I draw nice circles, decent circles at least. So when I tell you draw that, it means I'm talking about drawing them on the circle. So I'm having my 3 circles here. And okay, Draw 180. I always start drawing from the positive x-axis. Now 180 we know is half of 360 because 360 divided by 2 is 180. So I'm going to start from here and half of a rotation around the circle. So that's the 180. So the terminal side is this line. So that's the terminal side of my angle. Always we start counting from here. 90. 90 is basically a fourth of 360. 360 divided by 4. So again, to mark it, so that's the positive x-axis, I need to go 90. So this will be the mark. So that's my 90 degree. And that's my terminal side right there. Minus 90. Again, I start from the positive x-axis. Minus tells me you have to go this way, clockwise. And I go 90 degrees clockwise. So this is minus 90. And I put the arrow to signal that I'm going clockwise. And this is my terminal side right there. All right. Part 2. As you know, guys, I always have worksheet for you. So I have a worksheet on bright space and pull it up in front of you. Please pull the worksheet in front of you. And we're going to work on some of the problems together to have a very good understanding of angle measurement. Do you guys pulled it? So in case you don't see well here, you'll have it in front of you. All right. So mark the following angle. We did 180. We did 90. Now, minus 45. Again, that's my positive axis. Minus 45, I need to go 45 units in this direction, which is halfway. So that's my minus 45. So this is minus 45 degrees. Oh, sorry, this is plus 45. My apology. Minus 45. Okay. Plus 45 from the positive x-axis, I go 45, which is halfway through. That's my side. Okay. Now 375. I give you a minute where the 375 is going to be. So I'm going to work on that. And I want you to give me 375. Where is this going to be? All of you try to make a circle and kind of figure it out. Where is 375 going to be? It's more than 360. We know that much. Anybody? 375 is 360 plus how much? One full rotation plus the 15 degrees, right? That's what 360 is. So 375 is the 360 plus. So how are we going to mark it? Again, we start from here, and that's positive. We need to go 360 plus 15. So we start from here. We go a full rotation, as you guys said, of 360, but then I'll add another 15 degrees, and that's my angle. So it's a full rotation of 360 plus the 15 degrees. It means this here, this little piece here is 15. So my whole angle is 375. So it's this whole rotation plus the 15 degrees. So that's the terminal side of my angle. Okay. Now, 740. I want you guys to tell me 740 where it is. So you have to relate it. 740 is way more than 360. How many more? Okay, everybody. So now, usually we memorize 360 and 360. So if I add 360, it's still very far away from 740. I add another 360. I am still at 720. To hit 740, I think I need to add 20. Am I right? Yes. So what is that? 360 is one full rotation. Another full rotation. and then another 20 degrees. So we're gonna start from here. One rotation, that's the 360. Another rotation, that's my other 360, and then I add 20. So up here. So this angle here, this is 20, and that's really my terminal side. So if the angle is way above 360, you ask yourself, how many 360s is there and how much is left over? So in 740, we have two 360s, and then I have 20 left. And that will be how we measure the angle. All right, number two. Number two is also crucial to understand angle measurement. An angle theta is marked to you. Mark on the circles the following angles. So that's why I give you the paper in front of you so you know. This is my angle theta. So this time I did not give you any specific angle. And this is theta, this little bit here, this little bit here, this little bit here, and this little bit here. That's my angle theta within a circle. So I'm giving you the theta, and I want you to mark minus theta. What is minus theta? I give you 30 seconds, and I'm going to ask one of you, how shall I draw the minus theta? You know, guys, the worksheet is in front of you in case you don't see very clearly. So I want the first one. Where will minus theta be in my picture? Anybody ready? It doesn't have to be minus 30. Theta is any angle. So this is a little bit more abstract. I don't want to give it a value. Regardless where, yeah, now I'm getting in the fourth quadrant. Very good. So if this is theta, minus theta is exactly the same. That's minus theta. It's the same thing. Whatever theta is, minus theta is this one. So if I want to mark minus theta, this will be the terminal side of it. Okay, so if this is theta, so it's basically the symmetric. Basically, it's like flipping this with respect to the x-axis because those two angles are exactly the same. So as you guys said, it totally reflect across the x-axis. So if I know where theta is, minus theta is really staring at us. All right, part two. Probably this is a little bit harder, but it's crucial we understand this picture before I hit sine and cosine. This is my theta. My question is mark on the circle theta, add to it 180 degrees. Okay, so the first one we just reflect across the x-axis. That's really well minus. Now theta plus 180 degrees. I want you to mark it down, then I'm going to pick one of you to tell me what do you think we get, and then we talk about it. So what is theta plus 180? Where is it going to be? Not yet. I will call you in 30 seconds, Daniel. You will be my victim. Okay, Daniel, where do you think we're going to end up? Daniel? Yes, I did say your name. In the third quadrant. Okay, that's good. Can you be more specific? In talk symmetry. Can you be a little bit more specific? We end up in the third quadrant, you're absolutely correct. Who can be more specific than that? I didn't give you a value for theta. Reflected diagonally. This is getting better. So let's see exactly what they are talking about. If this is theta, I know that we don't know what it is, but it doesn't really matter. How much I'm going to add to it? 180 80 degrees. It means this is my theta. I'm going to add to it 180. So it means I'm going to add to it that much. From here to here, so that's 180. And that's the theta. So this is theta. I'm going to add to it 180. So this is the whole thing. Now it's theta plus 180. So it's as your classmate is, it's basically, it's not the reflection across the y-axis. No, it's reflection across the origin. Or if you want, is the total opposite to it diagonally. If this is theta, theta plus 180 is the one opposite to theta along the diagonal. So that's theta, and that will be the terminal side of theta plus 180. So it's not a reflection across the y-axis. It's either reflection across the origin, so it's the diagonal one, or reflection on x, then on y. That's correct. All right. Now, theta plus 360. Again, I want it to be marked on the axis. And so basically, I'm going to emphasize, so in this case, that's the terminal side. That's the terminal side of theta plus 180. It's diagonally opposite to where theta is. Now, theta plus 360. Again, where we're going to end up. So take theta and add 360. So we talk what its 360 is. Yeah, I'm still calling people. Yeah, because it's not going to move. It is going, I mean, would it be back to where we started? Exactly, back what we started. So this is theta. So the terminal side is not going to change. This is theta. When I add 360, it means I'm adding a whole rotation up to here. That's the 360. Okay, so this is my theta. I'm adding the 360. So from here, I'm starting to add the 360. But the 360, it means you have to go all around the circle. So that's the terminal side. So that the terminal side of theta is the same as the terminal side of theta plus 360. Okay. It doesn't move, it actually rotates. It's not it doesn't move. It rotates and go back to where it started. So it doesn't move, I will not accept it. It's we're gonna have a full revolution and come back where it started. Now, 180 minus theta. 180 minus theta. I want you to think about it a little bit. Where does it end up? So start with 180, and then you take theta away. Theta is here. This is theta. This is the angle theta, right there.
Can theta be greater than 180?
Not in my scenario now. Let's have a simple scenario where theta is between 0 and 90. Are you with me?
Yeah.
Yeah. So I don't want to make it more complicated. I just really logically, yes, of course. But in my picture, I'm going to make sure that theta remain between 0 and 190, not to make the concept harder, because I want you to see it graphically. I mean, I want you to be able to understand the picture. Okay, I'm giving you a minute, okay, to understand. Keep thinking, keep thinking. And the way I want you to do the following. Take 180 and then take away theta from it. Probably this would make it easier for you. Think of it this way, 180, and then take theta away from it. Okay, okay, now we're getting better now. We're getting better. You guys giving me better answers now. Okay, Tim Da Silva. Did you have any idea? Tim?
Theta would be in quadrant 2 because you said it,
Because,
right?
not theta, 180 minus theta.
You
That's theta.
okay, but the angle 180 minus theta, the angle would be in quadrant 2 because theta is between, like you said, 0 and 90. So
yeah, but where in quadrant 2? You're right in quadrant 2, but I want you to be very, very specific.
but okay, wait.
Using I want you to use the idea of symmetry. That's really what I want.
It would wait. So it would be like it would be a reflection.
With
Well,
respect. You're right. Keep going.
How do I describe this? Wait. So if say that theta is 30, right?
Let us say theta is 30. I'm with you.
So if that's the case, then 180 minus theta would equal 180 minus 30 would be 150, right? Which would be the exact would it be the mirror image?
Exactly. It will be the mirror image with respect to the y, it's reflection with respect to the y-axis. Because what did you do? You took 180. How much did you take away from it?
30.
30.
Right?
So 180 is from here to here, correct?
Right.
When you took the 30, it means you took the same amount as this one. Exact same amount.
Right.
Basically, if you take so you took away that much.
Right. So it would be so what would that be called? The reflection
with respect to the y-axis.
Y-axis. Okay.
Deflection with respect to the y-axis. Okay?
Okay.
Yeah, exactly. So now if you have, so this is, you guys do it for 30, but even if you had 30, if you have 40, if you have 60, it's exactly the same logic, verbatim. So if this is theta, so now this is 180, that's the whole 180, and I'm going to take away from it the exact same amount. So I'm going to take from it exactly here, but I'm going to take from it is theta. And so the angle will be 180 minus theta, which is this one. So that's the terminal side. So that's the 180 minus theta. Now it's nice to take example to be able to visualize it, but even if theta equals 40, it's going to be the reflection. If theta equals 60, it's going to be the reflection. So 180, so the terminal side of 180 minus theta is the reflection of the terminal side of theta with respect to the y-axis. In other words, those are reflection of each other. That's the picture. That's the picture. This is theta, and this is 180 minus theta. The last one. Theta should be less, so 180 minus. Yeah, but you're right. It is in the second quadrant, but I want more than that. I want you not only to tell me in the second quadrant, I want you to tell me that it's symmetric with respect to the origin. It's the reflection with sorry, my apology. It's the reflection of theta with respect to the y-axis. I want you to see that as well, because that's where we're heading. The last one, 360 minus theta. Okay, now I'm getting good answers. Yeah, it's 360. So basically you're taking 360 degrees for rotation, but you're taking away a theta. So if this is theta and I take its reflection here, okay, so that's the 360, but I have to take theta away. So I'm going to erase this little piece right there. And that's really what I am talking about. So this piece here is theta. So those are equal. Those are absolutely equal. So it's 360 a full rotation, but I'm going to take theta away from it. So I'm going to end up right here. So it's a reflection with respect basically to the x-axis. And that's really the terminal side. So it's 360, so you get a full rotation, but you take this angle theta away from it. So this one and this one are absolutely equal to each other. And then you get a reflection here, but across the x-axis. That's what you get. Any questions before I move on? Because I'm going to introduce the definition of sine and cosine. Any questions about this problem? I'm going to assign it again because we will use those ideas tremendously. Okay, now I'm going to start sine and cosine, the definition, the formal definition of sine and cosine, the one that you guys will be using. Most of you will be using this definition. So before that, I'm going to say we're going to talk a lot about unit circle. Okay, what's the unit circle? Unit circle is nothing more than a circle of radius 1. Unit circle, so the minute you see the word unit circle, is the circle of radius 1. Okay, so unit circle is a radius of radius 1. So it's nothing more than the circle, but the radius is equal to 1. That's really what we mean by a unit circle. All right? Now, definition of sine and cosine. And this will be called the unit circle definition of sine and cosine. So I'm going to start this on a new piece of paper. Unit circle definition of sine and cosine. Unit circle definition of sine and cosine. Okay. Here is the idea. I will define here, but I'm going to we start with the unit circle. So we start with the unit circle. And what I want to define for you, what do we mean by sine of theta? And then I'm going to take an angle theta. And as we said a minute ago, all my measurement, we start from the positive x-axis. So I'm going to take an angle theta and realize this time I took my theta to be more than 90 degrees. So that's my angle theta. And I'm going to stop the line to here. Okay. And I'm going to take this point P. This point, I'm going to call it P. So I'm going to say, let P be the point. So we're going to say here, let P. Okay. Right here. So start with the unit circle. With the unit circle. And let P, which has coordinate, of course, this point P, be the point on the unit circle. That's crucial. On the unit circle, which is specified by the angle theta. And I will explain what do I mean by that. Specified by the angle theta. What does it mean this is specified by the angle theta? Because the book uses this language, I have to use it. Specified the angle theta, it means that OP, or is the origin of your circle, form an angle theta with the positive x-axis. With the positive x-axis. Okay, so we start with the unit circle. Let P of xy be the point on the unit circle specified by the angle theta. What does this specified by the angle theta mean? It means P is the point such that the line OP form an angle theta with the positive x-axis. Now we define the sine and cosine as follows. So we're going to define the sine and cosine as follows. The cosine of theta, which we denote by, of course we don't use the notation, is defined as follows. And this is my definition. That's D definition. I have the point P. This point has two coordinates, x and y. The cosine theta is defined to be the x coordinate of the point P. That's the definition. The sine of theta, which we denote by sin of theta, is defined to be the y coordinate of the point P. Okay, back to the picture. You have an angle theta. You take the point P, which is determined by theta. What's the cosine? And what's the sine? The cosine is the x coordinate of the point P. Whatever the point P is, that's what we mean by the cosine of theta. It means this coordinate from here to here. That's cosine theta. It's the x coordinate. The sine of theta is the y coordinate. So the y coordinate of the point P is the sine of theta. Is equal to y. So what is the definition of sine and cosine? So if I give you an angle, which we're going to do in a minute, an angle theta, I tell you what's the sine and cosine of theta, regardless what the measurement of theta is. There's one way to do it. You start with the unit circle. You take the point P, which is specified by theta. So if theta is 120, you take the line of the point P such that OP form an angle of 120 with the positive x-axis. This point will have coordinate. The cosine is the x coordinate. The sine of theta is the y coordinate. That's the definition of sine and cosine. And immediately we're going to practice this definition. Immediately. So we're going to do the following problem. All of us. I want you to do we're going to find the following. Okay, we're going to find the sine and cosine of a lot of angles. So that's my definition, and we're going to use this definition to find them. Okay, so find the following. Cosine of 90 degrees and the sine of 90 degrees. Remember, when I have a right triangle, cosine 90, sine 90 didn't make sense because in a right triangle, we don't have, the angle cannot be 90 degrees. So now what's the cosine of 90 and what's the sine of 90? Let's see how I'm going to follow the definition. First, I need to draw the point P that form an angle 90 with the positive x-axis. So the only way I can do that, I have to go back to my unit circle. Back to my unit circle. That's my unit circle. And I want to take the P that form an angle of 90. So this positive x-axis, an angle of 90, that's a 90 degrees. That's my point P. Now, this point have x and y coordinate. What is the coordinate of this point P? Quickly. What are the coordinates of this point P? Remember, that's the unit circle. That's the unit circle. So the coordinates of this point P are 0 and 1. Now, what's the cosine and the sine? The cosine is the x coordinate. That's the definition. So the cosine here is equal to 0 because x coordinate of P is 0. What is the sine of 90? It's the y coordinate. So this is the sine of 90. So the sine of 90 is equal to 1. That's what's the sine and cosine. Let's practice this a little bit more. So because the y coordinate of P is 1. Okay, so what's the cosine 90? What's the sine of 90? You don't even have to memorize it. You draw the unit circle, you take an angle 90. Then you find the coordinate of this point, 0, 1. X is the cosine, the Y is the sine. Okay. Now I want you to do the following for me. So we're going to practice the basic sine, the basic angle. Suppose I ask you to find the cosine of 180 and the sine of 180. No calculator in use, and I want you to verbatim repeat the process. What does it mean? You take the point on the unit circle that corresponds to the angle 180. You find its sine, you find its x and y coordinate. Its x coordinate is the cosine, that's the definition. That's what it is, that's how we define. And the sine is 180. So I give you a minute to give me values. Every one of you is responsible. I'm going to pick one of you to give me the values. Anthony Vasquez, what did you come up with? Minus, okay, all right, so this is the coordinate of the point. So first we have to draw the point that corresponds to the angle 180, the point P. So I start from here, and this is the 180. So the point on the unit circle, which is specified by this angle, is this point here. It's -1 and a 0. Very good. What is the cosine now of 180? The cosine is which coordinate? The x coordinate. So what's the x coordinate here? -1. So the cosine of 180 is -1, because the x coordinate of P is -1. Okay. What's the sine of 180? 0, because that's the y coordinate. Okay, so you don't even have to memorize those numbers, because you can just immediately figure them out. You want cosine 180, you go back to your picture. Okay, which point P I'm interested in? That's the point P. This is the cosine, the x coordinate, and this is the sine. All right. Let me see one more, I guess. Okay, one more. Which one I want? Let us say I ask you what is the cosine of -90 degrees and the sine of -90 degrees. Okay, again, a minute, and I'm going to ask one of you. So you start with the angle, we start with the unit circle, the angle, the point, and the x and y. All right, so the students are giving me -90. It means we start from the positive x-axis and we go back here. So the point P is this one on the unit circle. That's the point that corresponds to it. The coordinates are 0 and -1. Good. So now the question, what is the cosine? Let me pick one. Asia Harris, what's the cosine and what's the sine? What's the cosine? Asia. I hope I'm pronouncing your name correctly. Okay, it's 0, she's right, because the x coordinate, that's the cosine. So that's 0. And the sine is the y coordinate. Is equal to -1. Okay, so the simple angles, of course, the simple angle, we can actually, just by understanding the picture, we can immediately find their sine and cosine. Right. The second question is along the same lines, you know, because I will not start, I want this definition to be actually drilled well in our head, is I'm going to give you a bunch of angles and I'm going to ask you a bunch of sines and cosine, and I'm going to ask you, are they positive or negative? What can you say? So my question is, decide if each of the quantities below is positive or negative. Positive, negative, or zero. Or zero, to cover all the bases. Okay, so I'm going to give you a bunch of stuff. And let us see. Easy stuff first. And we have to justify. Everything I write, you have to justify. Cosine of 40. Okay? Remember, I'm not asking you the value. I'm asking you if it's positive, negative, or zero, and you have to explain why. Is cosine of 40 positive, negative, or zero? All right, I'm getting, okay, I have one answer. First quadrant, yeah. So cosine 40, you know, I have no idea. I go to my unit circle. Okay, that's my unit circle. I draw the angle 40. 40, so it's a little bit less than 45, so it's less than halfway. And I take the point P. So that's my angle 40. So the terminal side is, of course, in the first quadrant. The cosine is the x-coordinate. That's the cosine, which is absolutely positive. So cosine 40 is positive. Positive because the terminal side, if you want, of the angle 40 is in first quadrant. Or if you want to say, because the point P is in the first quadrant. Right? So let's take other examples. Let me take sine of 135 degrees. Positive, negative, zero. I want you to draw circles. I want you to get into the habit of drawing circles. Okay, I'm getting a positive. I'm getting positive. Let me see. 135, where does this angle fall? So it's more than 90 and less than 180. So 135 is like 90 plus 45. So it's somewhere in here. That's 135. So that's my point P. And what's the sine? The sine is the y coordinate. That's the sine. That's the sine. Whatever this number is, which is, we don't know, you will know very soon, that's definitely a positive number. So this is positive because you can give me, so because again, the point P, if you want, is in quadrant 2, or you can say the terminal side is in the second quadrant. Actually, let's stick to that because the point P is in quadrant 2. So the y coordinate is positive. Okay. Now let me do two more. I have a minute to go. Let me take cosine of 220, let us say. Yeah. Positive, negative, or everybody screaming negative. Again, let us see. I am slower than you, so 220. Okay, this is 180 up to here, and that's 270. So 220 is somewhere right there. So that's 220 from here all the way there. Okay, so that's 220 degrees. The cosine is the x coordinate right there. That's the cosine. So this number here, if I had like good measurement, this number here is the cosine. So that's negative because the point P is in a quadrant 3. So the x coordinate is negative. Okay. The last one, and then we have to quit. What about cosine of 0 degrees? Okay, cosine of 0. Everybody is telling me 0. I don't know. I give you a minute to think about it. Right, what's the cosine of 0? It's not 0. It's not 0. But don't memorize, just draw your circle. Draw the circle. That's my circle. And I take the point on the unit circle that form an angle of 0. If this is the x-axis, the point on the unit circle that form an angle of 0 is this point right here. That's the point. The coordinate of this point is 1 and 0. And that's the cosine, the x-coordinate. That's the cosine of 0. So the cosine of 0 is actually equal to 1, which is obviously a positive number. Okay, so the cosine of 0 is not 0. Actually, the sine of 0, which is the y coordinate, so that's the sine of 0 degree, this is equal to 0. Okay, so what is the point that corresponds to the angle 0? The point that corresponds to 0 is this point. So it's the point on the unit circle that form an angle 0 with the x-axis. It's this one. It's this point right there. Okay. All right, so we stop today. Please, you do the homework. And for next time, if you guys have a printer at home, please print the worksheet I have for you. Because you're going to be working on it in class last time. It's very crucial. And what else? Monday is a day off, as you guys know. So next time we meet, it will be on Wednesday, and you will have your first quiz, which will cover what I did in 7.1, and it will cover what I did today. Okay? I put that again on Brightspace. Any questions before we let go? So please get the book. For those who don't have it, please get the book. As you realize, I have to use it. I have no other way. Any question before I let you go? How does the book look? How many questions on the quiz? How many questions on the quiz you have to ask me Tuesday evening? I'll answer you then. Don't worry about that. How does the book look? It's a good question. Does anyone, the book I have at home is not the way your book will look like. So does
I do.
Can we, let's see if I can pin you down. What's your name?
Jacob Stahorsky.
Okay, I have to find you. Lucas, okay, Lucas.
Wait, what volume is that? Because I ordered a.
It's the 5th edition.
Mine was like blue and purple looking.
Mine looks like this. It looks like green.
Yeah.
This, okay. Oh my goodness, everybody's gonna have a different book.
The hard part.
Mine has the exact same words as the problem we were doing earlier.
Okay, then you're fine. You're fine. Okay. The one I have, I will show it to you. It's this one.
Yeah.
Okay, but this is cover calculus, 153, 154. So if you have that, you're fine. That's the one I'm using. Okay, but there is another one. And you have to be careful with the edition. It has to be the 5th edition. Otherwise, the problem won't agree. It means what I assign will not be the one. So 5th edition, that's the one I have. Anybody has a different one? Anybody has a different one?
I have the one that's light green, but I got it straight from P&W bookstore. So
Okay, so show it. Can you show it to us? Do you have your camera on?
Yeah, I have that one too, and it had the exact same wording as the problem we were
Yeah.
doing
The one
today.
from PN, exactly. The one from PNW is the book, but this one also is the same thing, but it's different format. So if the one who has it, can you show it to us so everybody can see it?
third time's the charm, right?
Yeah, please turn the camera on this one. Do you guys let me pin him down if I can? I think I can add a pin. All right. Do you guys see the book? But that's for the one from PNW, right?
That's correct.
Okay. Any other questions about the book? Any other question, guys, about anything? All right. Enjoy your last weekend, long weekend. And I'll see you all on Wednesday. All right. So please make sure your quiz is on Wednesday. I'll put that on Brightspace and make sure you do the homework. In the meantime, if you have any questions, just shoot me an email. Okay. Bye-bye for now.
Have a great day.
Oh, thank you, guys.